Hello and welcome to tonight's talk about simplify IoT and AIoT development with the POCO C libraries and Make China IO Edge. This is a rather interesting topic, and I'm really happy to have here tonight because it's actually a sponsored talk. I probably should add. Thank you for that, Günter, and thank you for being here. Günter Obiltschnig, the lead author of POCO, is here with us tonight and giving this talk. Please take it away, Günter.
Thank you, Jens. Yeah, I'm excited to be here tonight and talk a bit about the things that I like doing in my professional career. For those who don't know me yet, I'm Günter Obiltschnig. I'm mostly known as the founder and contributor to the POCO C libraries, which is one of those general purpose C++ libraries available on GitHub and which has been used quite a lot in the last 20 years, actually, almost. And besides that, I also have my own company called Applied Informatics, which handles like the commercial things of what I do. I've been a C++ developer since the early 1990s, so quite a long time. So I think I started playing around with C++ around, I think 1991 it was. Back then, it wasn't really C++. It was a thing called C with classes. Because for the computers that were available to me as a student back then, C++ was still too big, so it was like a shrink down variant of C with classes. And gradually I moved then to real C++, did some internships where I got to work on very nice Sun workstations, where we did very exciting stuff in the field of quality control and testing in semiconductor manufacturing. And this is basically how my C++ career started. A quick overview of what I want to talk about today. So basically the talk will be split in two parts. I will first talk about the POCO C++ libraries, a bit about the history, how it came to be, and also a few words about the current status and the plans where we are going. And then I'll talk about my other project, which is called Machine.io, which of course builds on the POCO C++ libraries, and which is targeted towards IoT and AI in IoT applications. And for the most part, the talk today will more be like storytelling. It will not be very technical. I will probably show some minor technical details, but not too much. It will be more, what I have been like experienced in the last 20 years. So let's start with a quick overview about the POCO C++ libraries. There was something that Bjarne Stroustrup said some time ago about C++. Without a good library, most interesting tasks are hard to do in C++, but given a good library, almost any task can be made easy. Obviously, especially in the beginning of C++, C++ lacked for a large part the good library part. Of course, at one point, the STL came along, which helped a great bit. But still, if you wanted to do things like network programming in the early 2000s and participate in the World Wide Web and do all the interesting things that came up like web services and so on, it was a bit hard to do in C++. We had to do a lot of low-level things. Actually, a couple of years ago, I spent some time in the United States and also visited the Napa Valley. And on the way in the car, I found this nice road sign, the POCO Way. There are certain things that we do in POCO which might not be the same as in some other libraries. We do it in the POCO way. The whole thing has cannot even believe it myself, been around for 20 years now. We have now in the POCO C++ libraries around 350,000 lines of C++ code, plus a couple of thousand lines C code that we use from other dependencies like XPath, XML parser, and some other stuff. We have 1,200 classes, and we will soon have 8,300 stars actually on GitHub, which is quite nice. Also, we have over the 20 years gotten around 200 people who have contributed code to the POCO C++ libraries, which is also very nice. So how came it to be? Well, basically, it started it started in 2004. I had been doing a couple of years' work in the semiconductor manufacturing industry, mostly doing C++ programming. And as it was back then, we had to do a lot of low-level and also programming and also implementing our own libraries, because not much was available back then. And also we had to do like stuff on a number of different platforms. There was, of course, Windows. There were different Unix platforms like Solaris, HPUX, Linux also, of course, and obscure things like OpenVMS. So I kind of became an expert in programming C++ code that runs on many different platforms. And so I had this idea, I could write a book about that. And next thing I did in the summer or in the spring of 2004 is I wrote a book proposal, contacted some publishers, and one of the very big publishers actually got interested in my proposal and agreed to do my book. So in the summer of 2004, started working on my book and wrote a couple of chapters. And then sometime, I think it was end of August or something like that, I got a very sad email. Unfortunately, the publisher said, we have decided that we can no longer publish your book because, obviously 2004 was not the best time for C++. As you probably all know, it was a time when languages like Java and .NET were very popular, and also the Java people tended to say not very nice things about C++. And that was when I was sitting there and thinking what to do next. And actually for the book, I had came up with some patterns and some ideas for how to write cross-platform C++ code. And so what I did was started to put together a class library. And pretty much 20 years ago, that was when I started the work on the POCO libraries. And after about half a year, I had the first release ready, which, as you can see here, was already consisting of a couple of libraries, but otherwise, was still quite, should I say, simple. So back then we had basically the foundation library, which was doing the basic platform abstraction stuff. So we had things like file system access, of course, multi-threading, also a nice framework for logging, and a couple of other things. Then we had a network library, which things like HTTP client and server, and also things like support for protocols like SMTP for sending emails and so on. We had an XML library because obviously XML was very popular at the time. Then we had a general util library, which basically contains a simple framework for building command line applications and also server applications that had things like parsing of command line arguments and also handling of different configuration file formats. And then we had a simple library called dblite, which was a very thin wrapper of over SQLite which was also becoming popular back then. Then things moved on over the years. So basically the first release of the libraries was published in February 2005. And as it went, a couple of weeks after I put the whole thing back then on SourceForge, I got my first contributor, Alex, who started to helping me working on the POCO C++ libraries. And yeah, then went a couple of very exciting years, or if you see it from the C++ perspective, not so very exciting years, because we basically had C++ 98, and then we had C++ 03, and then not very much happened in the C++ world except the Tier 1 proposal. Nevertheless, there were some things that went in favor of C++. For example, the whole world of embedded systems. These things were finally like becoming powerful enough that you could actually use C++ on it. And also there was the beginning of embedded Linux. I can remember back around 2005, 2006, when you wanted to get like a development board to do embedded Linux development, you had to pay like 2,000 euros to get a very slow device with very little memory. Of course, everyone knows nowadays we have Raspberry Pi with 8 gigabytes of memory and very fast CPUs, so no comparison. But basically, that was when kind of the whole IoT thing also slowly came to be. Nowadays, if you look at a picture of the POCO C++ libraries, you can see it has grown quite a bit. We've added quite a number of libraries. Most notably, of course, a JSON library, because like JSON has in most fields, replaced XML as the format for configuration files and other data. Then we have the data library, which basically is an abstraction layer for different SQL-based databases. Then we have also clients for other databases like Redis, or as it's now called, or forked into Velki. Also MongoDB. We have a library called Active Record, which basically gives you the active record pattern, which is a nice little abstraction layer above the data library for usual standard database access. So you don't have to write a SQL query for every single thing you do, especially for pretty standard queries. Then we also have things like crypto support based on OpenSSL. We have TLS support for all the classes. We have JSON Web Tokens. We have since a couple of months a Prometheus library, so you can also export metrics that can then be imported in Prometheus or other monitoring tools, and you can then build nice dashboards out of it. And so as you can see from that whole picture, the direction where POCO goes is more like make POCO a good library for building modern cloud-based and internet-based applications. Of course, in 2011, we had the new C++ standard, C++ 11, which included a couple of new features, like, for example, threading library, and also some other stuff that was already in POCO. And of course, the newer standards that followed, like C++ 14, C++ 17, now C++ 20. So what's our relationship to that? Basically, we try to follow and use new C++ features as they can along. However, as a library that is used by a lot of people, for example, in embedded systems development, we cannot always be like at the top of C++ because people are often stuck with older compilers. And so we tend to be always a couple of versions behind the current C++ version. So right now for POCO development, we are basically on C++ 17, but we expect to go to C++ 20, not too far in the future. Of course, that has also brought a number of interesting challenges for us because, as I mentioned, the new C++ standards kind of have the same features or some of the same features that we have in POCO in the standard library. One example would be threading. Another example would be, for example, file system access with C++ 17, and also some other things. And of course, we have to think about that. And of course, the first idea we had was, we cannot completely get rid of, for example, the POCO thread class, because there is a lot of existing code out there that uses that, and we cannot simply expect from our users to rewrite their applications with the POCO thread class, or replacing the POCO thread class with std thread or stdj thread class. And also there were a number of other aspects that prevent us from doing that, because one of the ideas we had was, let's keep the POCO thread class, but implement it in terms of std thread. Problem is, std thread cannot do some of the things that POCO thread can do. Example for that would be, for example, in an embedded application, it's sometimes necessary to set the stack size, the maximum stack size of a thread, and you cannot do this with standard C++. So basically, that was one of the reasons we had to keep the POCO thread class and have it implemented on top of whatever thread API the operating system gives us. Another example would be the smart pointers, specifically shared pointer. So as you all know, C++ now has a shared pointer class. POCO also has a shared pointer class. And the idea was to simply implement the POCO shared pointer class with the std shared pointer class as the underlying implementation. And so we did a prototype of that. And then people started complaining because suddenly their code was a lot slower. Reason, of course, being that the std shared pointer class can do a lot more than the POCO shared pointer class, and therefore is a lot more complex, and also has not the same performance for that reason. So that was another reason why we basically decided, okay, let's keep the POCO shared pointer class. And we now have multiple shared pointer classes that we have to deal with, but that's the way it is. Same goes, of course, on with file system access. We have file system access classes in POCO. There are also file system classes now in C++ 17, but of course, the same problem. There is a lot of existing code out there that makes use of the POCO classes, so we cannot simply replace them. Another fun story that we can tell as the POCO community is, a couple of years ago, there was some discussion in the C++ standards community about like adding some basic networking support to the standard library. And I think that was even before Boost ASIO got popular. And so Alex and I, mostly Alex, had the idea basically to write a proposal based on the IP address class in POCO. The IP address class in POCO is very nice because it can contain both IPv4 and IPv6 addresses, which makes working with it very easy. Of course, once we submitted that to the standard committee, we got like very bad responses because people were screaming at us, we cannot use your implementation of an IP address because our application has to keep millions of IP addresses in memory, and your proposal uses way too much resources to do that. And yeah, that basically ended then our involvement in the C++ standards community. And yeah, we decided to keep doing things our way. And yeah, I think in the meantime, in C++, we at least have, do we have a URI class or just a proposal? I actually don't really know. Anyway, so what are our current plans? There will be a new release coming out, yeah, hopefully end of this month. It's mostly maintenance and bug fixes. A big amount of work that we now have to do is like updating or keeping our external dependencies up to date, because people keep finding security issues in C libraries or in the C libraries that we use. So we have to basically constantly have a look at them and yeah, incorporate the bug fixes. And then one other nice feature that Alex has been working on is stack trace support. So you will now have a compile time option to enable the exceptions that the POCO exception class basically to contain stack traces, which will make debugging things at runtime hopefully a lot easier. As I mentioned, the whole thing will be basically a compile time option. So if you don't want to have that overhead, you can simply leave it out, which is actually the default. So if you want that, you actually have to enable it. And then hopefully for later this year or early next year, finally some HTTP2 support for the network library, which is something that has been widely requested. And also finally, hopefully some YAML support so that you can basically use the YAML files with the POCO configuration framework. And there will be a couple of other things like yeah, JSON log formatter. And this is basically intended for people writing yeah, server applications in C++ that they want to integrate with all the different yeah, DevOps and monitoring frameworks out there. And finally, another thing that I'm again working on is a book. So after 20 years, there shall be sometime in the future a book that yeah, gives you some background information and some more code examples how to use the POCO libraries. Okay, so that much for now for the POCO libraries. Let's now move on to the next big thing called Machina.io. And this is something that I started working on, yeah, more than 10 years ago. And it's basically two different things that we now basically have under the Machina name. The first one is a product that we do called Machina Remote, which is basically a secure remote access solution for IoT devices. The basic problem that it solves is you have like an IoT device that is deployed somewhere in the field, can be industrial equipment, can be some kind of equipment that runs somewhere in a power station or whatever. And typically, a lot of embedded devices have web user interfaces nowadays for configuration. Now, the same question that everyone has is, once the device is out in the field, how can I access it? Of course, people have been using VPNs for that purpose, but yeah, that doesn't work like in every situation. And it's also, yeah, very complicated to set up, especially if you also want to give remote access possibilities to your end users. Then you have a whole lot of yeah, security things that are very hard to solve with VPN. So, for example, we have a customer in Germany for Machina Remote. They are building phone systems, office phone systems, basically. And these are basically embedded Linux devices that have a web user interface for configuration. And of course, people want to manage those devices remotely. Specifically, those devices are typically set up by a service provider, which is typically a local company that sells those devices. And typically, the end user does not set up these devices. So it's typically the company sells that device, comes to the office, sets up the system, configures it, and so on. And of course, these companies want to be able to remotely access those devices at the customer side because they don't want to drive to the customer for every little problem or every little feature that the customer wants changed. So with Machina Remote, they have now set up basically a solution where they have like almost 60,000 devices connected, and there is a very fine-grained way of controlling who has access to which device. And they also have integrated this with their app. So basically, end users can use their app also to connect back home to their phone system and, for example, check the mailbox or synchronize the address book wherever they are. And the other product under the Machina name is Machina Edge, which is the product that I'm going to talk about next. Basically, Machina Edge is built on top of POCO and basically extends POCO with features for building IoT devices, specifically in industrial IoT scenarios, but also in things like mobility, like the telematic system that we nowadays have in cars. And this is also that we kind of evolved out of the work that I did over the last 15 to 20 years in embedded device development. And there I noticed the kind of lack of a good framework for C++ that allows you to do all the things that you want to do, specifically now with IoT devices. Specifically, one feature that I wanted to have is I wanted to have a scripting language to do some of my programming. I love C++ and all, but of course, some things are much easier to do if you have a dynamically typed scripting language available. And this is when around about 12 years ago, I had the idea, there is this open source JavaScript implementation from Google called V8. I could have a look at it and see if I can do something interesting with it. Yeah, and then during some foggy afternoons in November 2013, I started playing around with it and doing some stuff. And I also had these other libraries that I had built over the years, on top of POCO, specifically the remoting framework and the open service platform. And basically, I started to combine these things. And this is basically how Machina Edge, or as it was called back then, was just Machina. Or in the beginning, actually, it was called the IoT platform or the IoT framework, for lack of a better name, came to be. And over the last couple of years, basically, this has grown into quite a big framework. As a foundation, of course, we use the POCO libraries, plus some additional libraries that are not part of the official POCO release. Like, for example, we have a POCO serial library for talking to serial ports. We also have a POCO Geo library for dealing with GPS coordinates and positioning information. And then, of course, a lot of things that we have built on top of that. The interesting thing is, if you look at the lower levels of this framework, specifically POCO, remoting, and open service platform, the same frameworks are also used for implementing our Machina Remote product, which runs typically on some kind of cloud server. And I think this tells a bit about the scalability that we have with this whole framework. So on top of that, then we have IoT-specific features. Like there are a number of things that you need in order to build an IoT system. Specifically, you need to implement certain communication protocols. Most prominent one in MQTT space is, of course, MQTT. But there are also lower-level protocols that you need to support in industrial automation environments, like Modbus or CANopen, or Step 7 for talking to Siemens PLC, also OPC UA, which is a big topic in industrial automation and so on. Then, of course, also things like Bluetooth LE, and of course, legacy stuff like the good old serial port. So we have a number of implementations of all of that. Then we also have some abstractions for dealing with sensor data, which is a nice feature, because when you write a code, for example, that deals with, in the simplest case now, like a temperature value, you typically get the temperature value from some kind of sensor. And thanks to the sensors and data point abstractions, you can basically write your code in a generic way. So you don't have to care which sensor your temperature value comes. You just basically deal with the temperature value and some meta information, of course. And the rest can be basically kept in the configuration, or at least outside your so-called business logic. And then we also have a number of other services that we provide to the people writing code on our platform. Last but not least, there is also a web user interface on top of it. And yeah, we will see that at the end when I show you a quick demo. There are two frameworks that I want to talk at least a few minutes about, that are part of Machina.io and that are also built on top of the POCO framework. The first one is a library or a framework called Remoting. The original inspiration came from these RPC implementations that were back then available for .NET and Java. And yeah, I wanted to have something similar and easy to use for C++. Some of you may remember Corba, which was yeah, a platform-independent RPC standard that I think was popular, or kind of popular, in the early 2000s. And yeah, I wanted to have something that's a bit easier to use, specifically for C++ developers. So basically the idea was, yeah, I don't want to have an external IDL. What I want to do is I want to have my C++ classes, and then, of course, due to the lack of reflection in C++, I had to find a way how to get basically the necessary information for serialization of data types and so on into the code. And the idea was basically to add some special comments to a header file. And basically the idea was, you just take your C++ class, add some annotations, then we have a code generator that passes the header files, generates the necessary code for doing all the magic for network communication and so on. And then you're good to go. At least that's the idea. Of course, everyone knows that it's a very bad idea to just take an existing C++ code and make it into a remote service. because typically the way that C++ classes are built and the way interfaces for remote services are built are fundamentally different. So typically what you do in order to create a remote service is you create a clean interface for your remote service in a C++ header, and then use that basically as your interface for the remote service. The remoting features framework has a number of very nice features. For example, it supports different communication transports, so you can do over TCP sockets or Unix domain sockets using a very efficient binary serialization format. And this is a very nice feature if you have a number of C++ applications either running on the same like embedded system, for example, or distributed across the network. So you have a very efficient way to send messages between those applications. Then, of course, we support other protocols like REST. So it's also a very easy way to create a REST API in C++. You basically, again, define your endpoints in C++ headers and then let the code generator run. And then basically you have implemented the REST API that can be perfectly integrated with all the other programming languages out there that support REST APIs. And then we support a number of other communication protocols like JSON RPC and also good old SOAP, which was also one of the hot things in the early 2000s. But interestingly is still being used, not just in enterprise environments, but also, for example, if you look at network cameras, there is actually a standard for network cameras called ONVIF that basically defines a network interface for cameras that's basically used for configuring cameras and also for basically taking pictures from cameras and so on. And this is based on the SOAP protocol, and at least since this year, our SOAP implementation can also talk to different network cameras. Then we also have authentication and authorization support, also in a very nice declarative ways, different ways of communication like request response, one-way method calls, and also events. So if your server wants to send something back to the client asynchronously, it's also possible to do that. And another interesting use case that we have for a remoting framework in Machina Edge is we have automatic bridging of C++ to Java code. So what you can do in Machina is you can write a service in C++ using the remoting framework, and then you automatically can call this service from your JavaScript code without having to write any bridging code. So that's one of the very nice things in Machina Edge. And then the other big framework is the OSP framework, which was back then inspired by a Java technology called OSGI, but adapted for C++, but can also be used like with other programming languages, like, for example, in Machina, you can also use it with JavaScript. And the idea behind this is basically to have a dynamic model system, or if you want to call it basically a plugin system that also covers basically deployment of bundles. So basically the idea is you have a file called a bundle, which is basically a zip file, and this file can contain code in the form of shared libraries. It can contain configuration data. It can contain, for example, things like resources for a website. It can contain scripts and basically anything else that you want to put into it. And then bundles have dependencies to other bundles. And inside the bundle, you also have a way to basically define services. And there is, of course, also a service registry so that different services can find each other. And if you combine all this together, you have a very nice way to build complex applications. And the way this is basically forces you to do the architecture is you are basically forced to think in a very interface-centric and service-specific way. And the nice side effect of this is that your code automatically, or your systems automatically become a lot more modular and a lot more maintainable. Yeah, I've already mentioned this automatic wrapping of C++ or automatic translation of JavaScript to C++ cores. This is an example. Say you want to, in this case, write a very simple sensor class that basically has a method that gives you the current sensor value and also has an event so that you basically get a notification when the sensor has changed. Then what you need to do with the remoting framework, you add a special comment at the top that says remote, and then code generator will go over that, do its magic, and generate a lot of source files that you have to add to your project. And then you can write JavaScript code like this. For example, you have the temperature sensor. You want to subscribe to the value change event, pass in a function, and then do something with the new sensor value. And all this basically without having to write any glue code. Now let's move on to the final part, where I want to talk a bit about the different applications that we have done in the last 1-2 years, specifically with Machina. And one that we did just in the last year was a very interesting project in the field of optimization of manufacturing processes. So basically, there was a company that was doing electronics, or it is a company that is doing electronics manufacturing, and they have a production process called matrix production, which is something that was like invented by the German Fraunhofer research agency. And the basic idea behind that is that you have basically a very flexible way to produce things. Your factory basically consists of different manufacturing cells that can be very quickly reconfigured, basically, so that you can use the same manufacturing cell to process different or to produce different products. The problem with that is you now have a situation where you have a factory, and in that factory you have a lot of different products that are in production, basically going from one production cell to the next. And then people working at that production cell basically have to decide, so which product are we going to process next? And it turned out that the people at those production cells were not very good at deciding which product to work on next. So they would basically take an arbitrary product that was waiting for processing and process it and then move on. And the problem was the whole manufacturing process became very chaotic, and it was very hard basically to predict when a certain product would be completed in the factory. And so basically the idea was to come up with an AI algorithm that would basically see how the different orders basically would move through the factory from one cell to the next. For that purpose, basically the factory was equipped with a tracking system. So basically for every crate that contains the products of an order, it would have some kind of RFID tag or something similar attached to it. And then there was some hardware basically that was tracking the different crates across the factory, and also a software system to manage that. So basically, the idea then was to plug into this tracking, or to connect to this tracking system, and then try to predict how long a certain product would need to complete basically its manufacturing run, and then give the workers at the station basically a list or a schedule in which they have basically to process the incoming orders. And basically this product was, or this algorithm was then built, and the algorithm itself was written in C++. And of course, algorithm alone doesn't do anything. You have to integrate the whole thing into the manufacturing environment. So there were things like the tracking data would be provided over MQTT. There were some REST APIs that we needed to call to get some meta information about the orders and so on. And so basically, we decided to do all that with Machina Edge. And basically what we did was we wrote a couple of JavaScripts that would do all the communication stuff and then feed the data into the AI algorithm. The AI algorithm would then basically for each production cell produce a schedule. The schedule would then be displayed to the workers at the station. And interestingly, that whole product was then deployed and became kind of a huge success, actually. The interesting thing was not just did the production times become shorter and predictable, and the factory was able to complete basically orders in time. Another interesting aspect from a social perspective was very interesting. Because the factory is actually running 24 hours a day, and there are basically 3 shifts working on each cell. And one of the things that happened in the old or previously was that basically the people in each shift would basically pick out the orders that were the simplest one to process and then work on those. And so basically the people that came after them in the next shift basically had all the complex orders to do, and were of course then a bit grumpy about the workers from the previous shift. And now basically that everyone basically gets a detailed list of what to do in which order, things are running much better. Another interesting project we did in the last 1.5 years was together with a partner again for a company in Israel, and they are basically producing fuel cell based power generators. And these power generators are used in a number of different cases. So for example, it can be used as an emergency power generator, replacing, for example, the older diesel-based power generation units. And they are also, for example, can be used for electric vehicle chargers to provide backup powers or to provide additional power during peak usage. Or they are also used, for example, as backup power in mobile phone base stations. And the company had a problem. Of course, such a fuel cell is a very complex system, and the fuel cell itself is controlled by a PLC that does all the real-time control and all the things. And then, of course, you need also a higher level system that manages the whole thing and also extracts the data, visualizes the data, and so on. And previously, they used basically an industrial PC for that with some custom written .NET application. And then they also had to integrate with some external sensors. Due to the fact that this was a PC, they couldn't use any cheaper industrial sensors. They had to use more expensive external sensors that had Ethernet interfaces and could be connected to the PC. And then they had some other issues with the whole software. So they decided to basically do something new. And then the idea was basically, instead of using a industrial PC, why not use one of those much cheaper IoT gateways like this one. This is basically an ARM-based computer, kind of similar to a Raspberry Pi, but a bit more industrialized and robust. And the thing also includes a mobile modem, so it can connect to the internet. And then as a framework, basically they used Machina Edge. So what this system basically has to do, it has to gather the real-time data that is coming from the PLC, store the data, process the data, and this has to be done in a flexible way. So they wanted to have some flexible rule engine to decide what happens, for example, when a certain data point reaches a certain value or similar situations. And this is basically where the JavaScript support in Machina came in very handy. So basically what they did is almost the entire thing was implemented in JavaScript. The only thing we did in C++ for that project were some specific protocols. The first one for communication with the PLC, which used a custom protocol. And the other one for integrating domain-specific protocols like DNP3. These are used, for example, in fields like electric grids. There are some custom protocols that are used to integrate these systems into the basically IT systems of an electricity grid provider. And so for that purpose, we used an existing C++ library, integrated that with Machina, and made it basically also available to JavaScript. Apart from that, the whole system does a number of other things, like it has a very nice web user interface to visualize the data. It's very flexible, so it can easily be used in different variants of the fuel cell device. It can be changed by the technicians that are setting up the systems on site. And the customer has been very happy with that system. One of the things that made the customer very happy was the cost reduction. So instead of basically paying like 3,000 euros per fuel cell generator unit for the industrial PC and all the external sensors, it's now like 300 or 400 euros for the same thing. Yeah, and this, of course, used basically all of the different features that we have in Machina. So it really was a very interesting project that we did together with the partner. Yeah, and the final thing, also again, industrial application, was done by our partner company, ALF1. And this is actually in a steel mill in Spain. They were facing some inefficiencies in their production. They had some problems with communication in their central control system that were causing real troubles and slowing down basically their production process. And so they implemented their own kind of solution on top of Machina that they then used in the factory to solve the issues. And the result of that was like a 30% increase in production, which is quite a lot. And there are also some other very interesting side effects, like, for example, lower electricity usage. Because, as you all know, as C++ developers, C++ code is very efficient, especially if you compare it to things like Java code or Python code. That easily becomes noticeable because you can do something in C++ with a lot less hardware than would be required, for example, for a Java-based system. This also means they were basically able to run the whole thing on much smaller servers, again, saving a lot of cost, and also with great stability. And this is basically the project, the product that the LF1 guys, which is actually Alex company, the other contributor to the POCO libraries, builds. So at the lower level, basically they are building on top of Machina Edge, and then basically they add their own specific features that are targeted towards industrial automation applications. And finally, telematics control units, another huge application area for Machina Edge. Won't tell you a lot about it, but basically the TCU or telematics control unit is basically the smartphone that is built into every modern car that has been built in the last 5 to 6 years or so. And there are now 12 to 15 million cars basically out there sold by different car brands that have a telematics control unit built in that runs Machina Edge. Good. And with that, I think since we're already a bit late in the call, I'll just give you a very brief demo, and then we will immediately move to the Q&A part. So as a demo, I will show you something that I did with Machina for my own home. So
Günter, I think we have finite time, so take your time as a demo.
Yeah. Actually, I built my own house in the last 3 years, and as part of that, of course, I also wanted to do some smart home things, and of course, I had to do this with Machina Edge. And so I have basically a little demo of what I do. So basically, throughout my home, I have a number of different systems that have IoT capabilities. So, for example, there is the heating system, the heat pump that I'm using that gives me some data. Then in every room in my home, I have a Bluetooth LE-based sensor, a RubyTech, basically, that measures temperature and humidity. Then I have a weather sensor outside of my house that measures, again, temperature, humidity, and also wind, and a couple of other things. And what I wanted to do is basically collect all the different sensor data, write it into a time series database. In this case, it's InfluxDB, and then create some nice dashboards with Grafana to basically get an overview of what's going on in my house. And so in this case, I have Machina Edge running as a Docker container on a Synology disk station that's running in my house. And what you see here basically is pretty much the built-in user interface that comes with Machina Edge. It's not the most modern or most nice user interface, but it gets the job done. Also, the idea is that everything in Machina Edge basically is implemented as a bundle or as a plugin, if you want to use that word, and can be exchanged by something else. And this you can see here. If you go to the bundles application, you can here see all the different bundles that make up this application, or in this case, Machina Edge. So you can see here we have, in this case, 112 bundles already. And actually, most of those bundles are part of Machina. So the only bundles that I added were the different data logger bundles, for example, for the Ruby tags, for another sensor that I have for the weather station, and also like here for the heating system. And the rest is pretty much basic standard Machine I/O stuff. So what you can do is now, of course, click on a bundle. Or maybe use this one, and then you can see meter information like symbolic name, version number, and also dependencies. What you also can do is you can click install and then take a bundle file, for example, from your local hard drive, drag it here and install a new bundle. And you can also start and stop bundles. So if you go back to the web interface, you can see we have here a number of applications like the sensor log, bundles console, and so on. And each of these applications itself is a bundle. So I can, for example, look for the sensor log bundle, click it, click on stop, and if I go back to the screen, you can see this application is suddenly gone because the bundle was stopped. Yeah, and then we have the concept of data points, which basically provides abstractions for data that you typically get from different sensors. The whole thing can be organized in a hierarchical way. So I have here my different rooms, for example. Yeah, let's take the kitchen maybe. In the kitchen, I have a Ruby tag, and in the Ruby tag, you can see it measures currently a temperature of 24 degrees. The humidity is 54%, and it also measures the air pressure, ambient air pressure, and also it gives me basically the voltage of the internal battery. And then I have a script basically, or different scripts that take all that data from the different APIs and other endpoints that provide the data. For example, the data for the Ruby tags comes over MQTT. I have a Ruby gateway installed, basically that gets the data wirelessly over Bluetooth from all the different sensors and then publishes the data to an MQTT topic. So I have a little script written in JavaScript that basically receives those MQTT messages and then updates the data points and also writes the data into an InfluxDB database. The same happens, for example, for the heating system. In the heating system, it's a bit more complicated because the manufacturer of the heating system does not provide an official API for end users. And I solved this in such a way that there are other home automation systems like Home Assistant and so on available. And those have a pretty good community that faces basically the same problems. And so basically some people from that community basically reverse engineered the REST API that is used between the smartphone app that the manufacturer provides. And they have basically implemented that in that case, Python. So basically what I did was I kind of looked at the Python code, found out the endpoints, and re-implemented the same here in JavaScript. Which has a bit of challenges because like it happens yesterday, suddenly the system stopped working because apparently with the last upgrade to the app, the manufacturer has changed the API. And so I had like to start this morning a debug session looking at where the specific problem was. Turned out they no longer support a specific feature in the API, so I had to kind of work around that, and now it's working again. Yeah, you have also things like an overview here of all the different services. You can see with every service that you register, every service basically is implemented as a C++ class. And every service can also have metadata, and this metadata is very handy because sometimes you want to search for a specific service, but you don't know which service or what is the name of the service that you want to call. Say you have like a temperature sensor and you want to read the temperature, and now you can have different kind of temperature sensors. Like you can have one, for example, in this case, the Ruvitec, or you can have the temperature sensor or the temperature value from the heating system. And therefore, we have this abstraction in Machina Edge that basically gives you the same interface no matter which in which way the specific sensor is implemented. And basically what you can do is then you want to search, if you want to search for temperature sensors, you can basically look for you can basically use a query language that is built into Machina or specifically the OSP framework and specify you want, for example, a data point that that's the wrong one. A data point basically that gives you the temperature, and then the framework basically will give you all data points for all the temperature sensors. Okay, and as I've mentioned, all the data gets written to InfluxDB time series database, and connected to that is a Grafana instance that's also running locally on the same disk station, and this I use basically for visualizing all the different data. So you have here some data from the heating system. I have data from the different rooms, temperature and humidity, and so on. Good, and with that, I'd like to finish and move on to answering any questions.
Thank you for the nice talk, Günter. We have a few questions. Let's start with the C++ questions on POCO. There was a question about coroutines. What do you think about coroutines? Do you have a plan to add coroutine support into POCO?
I don't have specific plans yet, but I have, let's say, I have some ideas what could be done with coroutines. But yeah, one of the problems, of course, that I have is lots of ideas, but not so much time to do things. But it's definitely something that we are thinking about. It's actually, I guess, the same topic that we have with a lot of things that are coming to C++ now, because what people probably noticing, a lot of the new features that are coming to C++ are kind of very low level and very, would say, hard to use. And so, for example, one of the things that I had to deal with was this new time zone support in C++ 20, which is like, yeah, not really very developer friendly. So basically you have to first have a PhD like in time zone theory in order to use it. And one of the ideas is also to have some easier to use classes on top of that. And I think the same is probably true for coroutines, which, yeah, you need to have something built on top of it to make it usable.
Yeah, I mean, there has been coroutine support like in Boost before the standard.
Yeah.
But if you like actually want to explicitly support what's in the standard, that will be a lot of work. And maybe with more upcoming standards, it will be better. You mentioned network programming. So someone asked, like, curl is still the most popular library. How do you compare POCO with curl, especially for HTTPS, TLS related use cases? Does POCO support all the lower level capabilities as curl?
I think for HTTPS, we are pretty much on par, except for HTTP2 support, which we currently don't have. But as I mentioned before, it is planned for the near future. So I think with the POCO HTTP client, you can do all that you need to do, like for HTTP. Of course, curl has some support for a couple of other protocols probably that we don't have in POCO, but at least on the HTTP side, I think there is not much that you could maybe do with curl that you cannot do with POCO.
And from LinkedIn, there's a question about, like, do you support like more database modeling oriented ways, or is it just database classes in POCO?
Yeah, this is actually this active record library that is relatively new in POCO. I built it a couple of years ago. So it basically implements this active record pattern from, I think there was a book called Patterns of Enterprise Architecture or something like that. But it's a very simple, lightweight way of doing things. So I did not want to build like a huge ORM framework that you might find in Java or .NET Word. I wanted to have something lightweight, just covers basically the most basic usage. So basically give me an object with a certain ID, or give me a list of all objects with a certain ID. And the way this works basically is you have a configuration file or an XML file where you basically specify your database schema. And we then have a small code generator basically that generates C++ classes out of that, and also basically the most basic queries. And then, you can basically do that. And of course, it's built on top of the POCO data library. So it works with different databases like MySQL and Postgres and SQLite and ODBC.
More general question on how are you, like, comparison of or advantages you think with respect to some IP protocol?
Actually, the SUM IP protocol would be just another protocol that can be implemented with the POCO remoting framework. And this is actually what we did for a customer. So basically, you now have the way to specify basically your SUM IP services as C++ classes, and then basically use the underlying SUM IP serialization and data format and network protocol as an implementation basically of the remoting framework. So this is currently not publicly available because we did this for a specific customer, but and also for a specific underlying SUM IP implementation. But we are thinking about doing this in a general sense and using like, for example, vSUM IP as an underlying implementation. The problem actually that I found with all the existing SUM IP implementation is they are pretty low level. So basically they implement the basic framing of the network packets, but they don't do serialization. So you still have basically to manually build your network packets in terms of your user data. And this is something where the remoting framework saves you a lot of work because it does all the serialization for you.
Yeah. In that context, I have actually a question, because years ago I implemented stun turn for a client, or like in a client, and we found some C++ framework which supported stun turn, which was quite difficult to find, but then we had one and it was like huge, and we used like one tiny bit of it. And so it would be interesting to know, it's like, have you worked with the stun turn protocol? Is that still...
No, I haven't yet.
Okay. Question on licensing. Is Machina.io proprietary? Is it open source?
It's put it this way, we have like an open core model. So basically, we have a version of Machina Edge that is available under the GPL on GitHub. But we also offer a commercial version that has more features, and but also the commercial version that we offer is basically provided in source code. Actually, when I started Machina Edge, it was actually in the beginning available under the Apache license, so it was basically free to use for everyone. But I got kind of motivated to change that after I noticed it was used in a lot of cars from different manufacturers, and it's a bit hard if you put out everything and for free, and at one point you need to find a way to also get paid for your work. But that's a common theme in open source in general, and still I think an unsolved problem.
There was a programming language question on LinkedIn. Like, why do you follow C++ and JavaScript and not like Go from the server? Or like generally?
Yeah, generally because I have been programming C++ for many years. I have built a lot of code in C++ that I can use, and I'm not really motivated in repeating the same again in a different programming language.
All right. Let me go to the next question. How do you see Machina technology capturing the edge IoT growth as it is now maturing faster?
Good question. Let's say we are working on that. As you can see, I've showed you a couple of interesting examples where Machina Edge has been used. I think there is still a good market for that, because if you look at some of the other things that are around in the IoT space, or specifically in the edge space, it's a lot of stuff basically that comes from people who traditionally came from a cloud background, and then discovered the edge space and basically began by downscaling what they did for cloud for edge devices. So for example, there is a framework called EdgeX that is, I think, done by the Linux Foundation, and mostly I think sponsored by Dell. So it's really targeted for servers that are running on the edge and not so much for typically IoT gateways. And also last time I checked, so the hardware requirements were at least like a minimum of 1 gigabyte of RAM, which nowadays, of course, is no longer that much of an issue as it was a couple of years ago. But as we've seen from the example from the steel mill, efficiency, I think, is still a major point, especially, for example, if you can replace your industrial PC with a much cheaper IoT gateway and do more with that. So I think that whole performance thing, efficiency thing, is where I see a C++ based solution having a lot of advantages. Also, if you go to the whole thing with machine learning at the edge, a lot of that is C++, even if it's under the hood. And of course, it's much easier to integrate C++ machine learning framework with other C++ code than with some other stuff.
Sure. How's your experience as an open source maintainer?
It's the usual, should I say, mixed bag. So I've been doing this now for 20 years, and I've seen all the things. People screaming at you because they don't want to do C++, but because they're rather Java programmers, but kind of were forced to do C++, and now they have to use your framework, and it doesn't work exactly like what they know from Java, and everything is bad. Of course, positive thing, a lot of contributions by different people. Also, one of the big issues in open source development is you have a lot of people who contribute like a huge chunk of code to a project and then lose interest in it and leave the project, and basically the remaining core maintainers end up with an increasingly bigger amount of code that has to be maintained. And also of course, everyone likes open source. And even I think if people won't admit it, the main reason people like open source is because they get free stuff. Of course, there is, and it's funny because just the last 3 days I spent at the Open Source Summit Europe, which this year took part in Vienna. So I took the opportunity and traveled there with, due to the weather that we had in the last couple of days, was a whole different story. And there are some interesting things happening in the open source world that I find a bit concerning in some regards. I don't know if anyone has followed the situation with the Redis database. Basically, Redis is a key value store in-memory database that's very popular in cloud environment, and also in the POCO libraries we have a Redis client. And Redis was originally developed by a guy in Italy as a single-person project, and then eventually, basically, he built it as part of a startup that he was founding, doing some other stuff, and he needed basically a key value store, a fast one. And so he started building that, and that actually became his most famous product, because the startup originally, he founded originally, went bust. And again, he was hired by different companies like VMware and some others. And eventually there was also a company that basically started to commercialize the Redis product. And the typical way to monetize such a product is you offer it as a cloud service. The problem with offering as a cloud service is if your product is popular, then obviously AWS and Azure guys will notice it and start offering that product themselves. So you now, as a startup, find yourself getting competition from very big companies, which is not a funny situation to be. The usual way these companies then react is, we have this open source project that anyone can use, but we want to make money by offering it as a service. So how can we prevent AWS, for example, from providing it as a service? And they start doing funny things with the licensing. So it's no longer basically an open source license, but some kind of source available license. And this also what happened to Redis, I think this April or sometime around that. So basically they changed the license. And of course, the people from Amazon didn't really like that, and also some other people. So basically got together. They took the last open source version of the Redis code, forked it, and created a new product that was immediately put under the Linux Foundation. And now basically we have Velki as a replacement for Redis. And this probably ends from the reaction that I have seen, at least there, the Redis story probably. And the same thing happen to other things. Like there's this new open search project, which also took some other open source search engine that from one day to the other stopped being an open source engine, and so on. And a huge topic still is how do open source maintainer actually getting paid. So it's basically with the situation with POCO is it's basically a couple of smaller companies like my company or Alex company doing the main part of the work. Occasionally we get to do paid work, like for example Siemens paid us some money to implement certain features in POCO, which was a nice thing. And of course, we have some contributors that work at larger companies that also contribute some code. So yeah, it's sometimes as occasionally, like with everyone, every other work, from time to time, it gets a bit frustrating, and you're wondering why you're doing that, and then also
So
it's fun.
I think it's like a topic that we can go on. But
Yeah.
I thought like it would be nice to just follow up with like how does your commercial offering look? I mean, you talked about that I know it's difficult to get funding for open source, and I know the Qt licensing and what they do. Like they have like a device license and an application developer license.
And basically, we have a very simple licensing. So we have different packages basically that we offer. The one is the simpler one is called POCO Pro, which is just the remoting and the OSP libraries, and this is typically targeted at companies that are not doing strictly IoT things. So we have a lot of companies doing Windows applications, this kind of stuff, or server applications. And this is basically a one-time license fee, and you get basically the source code and can do as you wish, so to say. And then typically for Machina Edge, we have a similar licensing agreement, although we try to find a licensing agreement or a payment scheme that kind of works with the customer, so that there is no fixed pricing. It's more like how many devices do you want to put Machina, or do you want to put Machina into, and then we try to find an agreement.
Yeah, I understand you have an interest to so like when we talk about IoT, Edge, C++, etc., like security becomes more important. I thought like we should talk about that a little bit. Like, do you like run your own fuzzing, or have you had
For POCO, we don't run our own fuzzing, but POCO is now run as part of the Google, what's it called? Fuzzing thing. So
that's interesting.
Yeah. Also, they already found a couple of issues there, which we are usually trying to fix as quickly as possible. But so far, nothing real serious has been found. And usually, the main security issues that we have to deal with are often in the C libraries that we embed as part of POCO. For example, in the last recent years, a lot of issues in the export parser have come up. So we closely following their releases and try to incorporate their patches as soon as possible. And of course, in POCO itself, we try to do things the right way. So be very conservative with regards to working with pointers. So generally, we use smart pointers wherever possible. And we also have like our own buffer class that does some edge, some buffer overflow checking kind of stuff.
Yeah, I think like having the primitives right, and you said that you had smart pointers before they were in the standard.
And then we also do the usual stuff like running the test suites with all the sanitizers and this kind of stuff.
Yeah.
We try, as usual, we try to do the best as we can, but of course, our resources are limited, so we cannot probably do all that we should do, but we try to do our best.
But Google helps, of course.
Yeah.
So, regarding to Machina Edge, there's a question like, what are the main competitive options to your offering?
I think if you look at the C++ world, there is not much that is out there. Of course, there are some frameworks that other languages that use other languages like HX, and also the Linux Foundation has some lightweight stuff. I don't remember the name, but I think it's something that is written in C or something like that. And then there is also another project. I also don't have the name in my head, that is written in either Go or Rust. I don't remember.
Yeah, sure.
Actually, it's not that much that is out there in terms of. Of course, there is a lot of libraries that cover one aspect of what Machina does. So, for example, there are libraries that help you with talking to PLCs and stuff like that. And
okay. LinkedIn asks, do you plan to have some AI stuff in Machina Edge SDK?
Probably not directly in Machina Edge, because what I have seen is with the work that I've come in contact with in the AI space is very few AI projects are as simple as taking a neural network library and training a simple neural network and integrating it. The real interesting stuff is a lot more complicated. Generally, I'd say there are plenty of C++ frameworks or libraries for AI stuff already out there, and it's not too hard to integrate them with Machina. So I see no special need to have any specific AI features in Machina.
Yeah, it's an interesting and good argument that this basically is, on the client side, not like on your framework side. how is it like with the integration of Machina into the customer development environment? Are they available as libraries and via API integration and customer source code?
Yeah, from an integration perspective, it's basically a set of libraries that you can integrate. And there are actually different ways that you can use Machina. The easiest way is you basically take the entire Machina package and compile it and build it, and then you have something, as we have seen in my demo, basically, that already gives you something. And then you can build basically the libraries, can use the libraries basically to build your own bundles or your own extensions, your own services, and deploy them alongside with Machina. But what you also can do is you can just take some of the libraries from Machina that you need and completely build your own environment. So it's really very flexible from that perspective.
Yeah. We already talked about security, but there's like a specific question about, with the advent of more cybersecurity risks, how data security integrity is maintained in the communication with your stack.
There is no specific thing here. I mean, we do the usual stuff like using encrypted connections, HTTPS, or if you use MQTT, you have MQTT over TLS. But there is no specific thing that we do in the Machina framework for encryption, because this is typically handled at the protocol level.
But as far as I understand, POCO is part of Machina, so and POCO does support encryption, so you could like implement encryption for the critical things you want to encrypt and not trust the transport layer of encryption. Which I think brings us to the end. Thank you very much for being our guest today and giving this awesome talk.
It was a pleasure.
And with that, I think we're going to end the stream. If there's any questions more, you can reach out to Günter on LinkedIn. And if you're coming through Meetup, we'll send a message later when the video is online to everyone who subscribed to the event. So thank you very much. Any final words, Günter?
Yeah, thanks everyone for attending. I had a lot of fun giving that talk. And if you have any questions, you can reach me via LinkedIn. Also, the POCO project website is pocoproject.org. You can also find it over Google, of course. And Machina.io website is, as you would expect, machina.io. So if you have any questions, just feel free to reach out. So thanks a lot. And